Hello everybody and welcome to this episode of Programming and Algorithms. In this episode we're going to look at pseudocode. So pseudocode is like a made-up programming language. If we were programming for the computer, we'd program in binary. If we were programming for human beings, we'd program in English. So what we do is compromise somewhere in between, and we use a computer programming language. I'm sure you've heard of languages like C and C++ and Java, Pascal, BASIC, Modulo 2, Python, various languages like that. So those languages are supposed to be halfway between what a computer can understand and what a human can understand. And many people think it's kind of neither of them can understand it, but that's how we program. Because we're just learning to program though, we're going to ramp up to the programming language by using a language that's closer to English first, called pseudocode. Pseudocode is a design language. You can't compile it, the computer doesn't understand it, but it helps us explore how we should design our programs. And then it becomes a very simple step to move from pseudocode to English, or rather to the programming language, or pseudocode to English. Either way, it's understandable in English and it's understandable or convertible into a programming language. The kinds of programs we'll start off with are very simple, so there isn't a lot of difference between pseudocode and the programming language then, but as we get onto harder and harder problems, it'll become evident why we need this design language to help us before we go straight into programming. In fact, I always say the longer you spend designing, the less time you'll spend programming, whereas if you spend only a short amount of time designing, you're going to spend ages and ages working out how to do the program and making it successfully execute what it's supposed to be doing. So we like the idea of spending some time designing, then being very quick in our build, as opposed to a quick design and then spend 10 times as long on the build. So in general, when we're programming, the first thing we need to do is decide the name of the program, and that's always an important step. So if we're writing a program for calculating interest, a good name for that program is calculate interest. One word, no spaces, capitalizing each letter. We call that camel case because it kind of looks like two humps of a camel, calculate interest. So rather than putting spaces between the words or minus signs or underscores, we will prefer generally just to have all the words together, just capitalizing letters. In terms of the efficiency of programming, that helps for reasons we'll go into later. But if you use special characters, underscore, space, minus sign, it adds a tiny bit of computational time on to do that, whereas capitalizing each letter and using that standard, each first letter, helps us understand what the program is about. So we'll typically have first letter of each word capitalized, no spaces in between for program names, and we can use as long a name as we like if we're calculating simple interest or compound interest. If we're calculating compound interest for the year or whatever it is, it's as well to spell out the name as clearly as possible, because that's going to help you remember what the program is about, and if somebody else has to look at your program, it'll help them understand what the program is about. It's important to give that a very clear handle or name. So in pseudocode, which again is a structured design language, if I want to say I'm starting a program, I say I'm starting with the word program in capital letters, P-R-O-G-R-A-M, and then the name of the program. Then I'm going to put in a colon afterwards. So it's program name, and colon, always. We'll always finish our programs with the word end as well. It's nice to finish a program by saying end full stop, just to be clear for anybody who's reading it that this program doesn't continue on the next page or on the next screen or anything like that. So we indicate the program is finished by putting end at the end, and that's always the same. So the structure of every program we'll have is program name, colon. We'll do a bunch of stuff and then we'll end full stop with the end. That is in pseudocode now. When we implement that in a specific programming language, like Java or Pascal or Python or something like that, they might use slightly different symbols to represent these things, but it's the same meaning. So the semantics is the same, even if the syntax varies a little bit from programming language to language. But I want us, for this module in programming and algorithms, to focus specifically on how do we design good programs. So we're going to lead by using pseudocode, then we'll move on to our programming language afterwards. So in terms of pseudocode and in terms of programming in general, there's three concepts, three components that we must investigate in a lot of detail. The first component is called sequence, the second is called selection, and the third is called iteration. So sequence, selection, and iteration are our three best friends, and we'll spend a couple of episodes, subsequent episodes, investigating sequence, selection, and iteration. So thanks very much. I'll see you on the next episode.